Hello, welcome to the first lecture of Intro to Organic Chemistry, and in today's lecture, which is lecture number 1, we'll be learning how to draw organic molecules. So let's start off by saying, what the hell is all this? What does this represent? So basically, in a nutshell, organic chemists are pretty much lazy as heck. So we try to represent chemical formulas the easiest and fastest way as possible, and we do this by drawing line formulas. And I'll take you to the blackboard in a second, but first let's go over the rules of line formula, and we'll go over structural formula and condensed formula and the differences between these three. So let's talk about line formula first. So the first rule is every line segment represents a bond, and typically that bond is covalent. And the second rule is every endpoint or vertex represents a carbon atom. The third rule, hydrogen bonds are assumed to fill each carbon atom octet. And number 4, heteroatoms or atoms of elements other than hydrogen and carbon are explicitly written down. This includes nitrogen, oxygen, sulfur, and phosphorus. So let's go over the blackboard to better explain what I mean. So now we're here at the blackboard, and I pasted the rules I've set and the molecules we were talking about earlier. So let's just look at this one for a second, right? So let's see, we have lines, which represent bonds. Every endpoint, vertex, these represents carbon atoms. So let's try to write them down as is. So carbon here, carbon here, carbon here, carbons here. There we go, all the carbons. And hydrogen bonds are assumed to fill each carbon octet. So I'm not sure if you guys have taken general chemistry, but typically an octet is, in a nutshell, like you have 8 electrons around you, and each bond represents 2 electrons. So let's look at this carbon for a second. It has 1 bond attached to it, so it has 2 electrons that it shares or holds, basically, and we want to get it to 8 to get it filled. So now this is where hydrogens come in. It's implied that every carbon in this molecule, it has a filled octet. So in this case, we imply that this carbon has 3 hydrogens. So 1, 2, 3, 4, 5, 6, 7, 8 electrons. So this octet is filled. Let's look at this carbon. 2 bonds, 4 electrons. So we add 2 hydrogen bonds to it, and so on. This one has 1 hydrogen. This one has 2. This one has none, actually, because it has 4 bonds to carbons and has 8 electrons already. Octet is already filled. You get what I mean. So yeah. Let me just finish drawing this out because it goes to another definition. So in this case, we would call this representation a structural formula. And you see, like in a structural formula, we draw absolutely everything, each atom, each element, and every single bond. And you see how much effort drawing this took compared to drawing this. For example, I could just draw this. Done. This took 1/5 of the time it took to draw this. That's why we represent things in line formulas. So it's very important to understand the language of these drawings. So let's look at this one next. All right. So here we see some double bonds, and let's read our rule again. Every line segment represents a bond, and every endpoint or vertex represents a carbon atom. So let's draw the carbons first. And let's fill out the remaining bonds. It's not exact, but actually, yeah, we'll get into resonance later, but it should look something like this. Now let's look at this carbon. We have 3 bonds, so we have 6 electrons. So that means we imply there's 1 hydrogen. And same for this one, same for every single one of this. This is probably the most iconic molecule in organic chemistry, and this is called benzene. Right, a ring of 6 carbons, and you have 3 double bonds. And this molecule will become more important in later lectures when we talk about something like resonance, for example. And let's focus on this molecule now. Right, according to our rule, each vertice endpoint represents a carbon. Notice how in this line structure, line formula, we draw the oxygen and nitrogen. So that goes back to rule number 4. Heteroatoms, or atoms of elements other than hydrogen and carbon, are to be explicitly written down. So anything other than carbon and hydrogen, you write down. So let's see. And again, we implied hydrogens are bonded to carbons to make a full octet. So in this case, there would be 3 hydrogens bonded to this, 3 hydrogens bonded to that, and 3 hydrogens bonded to this. Alrighty, hopefully that made sense, and let's go back to the PowerPoint. Okay, so we're back here again, and let's move on. So it might be a little difficult to really understand like how many bonds is this and that. So a special rule my chemistry professor actually taught my class was the 4-3-2-1 rule. So like it's basically just this. In a uncharged stable molecule, organic molecule, carbon forms 4 bonds, nitrogen forms 3 bonds, oxygen forms 2 bonds, hydrogen forms 1 bond. And as long as you remember this, you're pretty much set for drawing organic molecules and knowing how many bonds each atom usually has, because you usually encounter these 4 mainly in organic chemistry. And just a quick note about condensed formula. So we had structural formula where you write everything out, bonds, atoms of every single element. Line structure, which is like laziness basically. You just draw lines and you refer back to the rules I've written down. And condensed formula is another way of representing chemical formulas or chemical molecules. Basically, in a nutshell, it can't be written down in one line and can be typed in something like a search engine like Google. An important note here is to not confuse it with molecular formula. These are 2 different definitions, and I've written something down. So basically, both are written on a single line of text. But molecular formulas only tells us the number of atoms of each element in a molecule. Condensed formulas gives us a little more info on how the molecule is structured, but it omits all lines. So this is an example. So this would be something like a condensed formulas, right? It gives us the idea of the structure, and it has no lines, no representation of bonds. It can be written down in a single line. This would be an example of a molecular formula. It could be written down in a single line, but it's very limited in its structural information. It tells us how many carbons there are, how many hydrogens there are, but this could be literally so many different types of structures. So it's important to distinguish between the 2. But yeah, that's it for today. Here are my socials and credits to the author that drew my model. The song is from Genshin Impact, Qing Yun Peak Theme. Of course, Yu Ping Chen is amazing. Here are some other great resources you might want to check out. And finally, as always, drink water, eat healthy, sleep 8 hours, exercise daily, and everything will be alright. Thank you for watching.